Alors, j'aimerais souligner ici la présence ce matin de gens de CISCO, dont notre keynote speaker, M. Jeff Seifert, qui est le CTO de CISCO au Canada. Il y a aussi Robert D'Agostino de CISCO, Christine Gauthier et Clément Vatrin, qui sont des gens de CISCO. Si vous avez des questions pour ces gens-là, ils seront présents aujourd'hui toute la journée. Ils seront heureux de répondre à vos questions. Clément aussi peut-être est chargé de traduire des questions pour Jeff s'il y a lieu. Tu t'es proposé gentiment, alors voilà. Alors, Jeff, en tant que directeur de la technologie chez CISCO Canada, Jeff fournit des conseils et des directives techniques concernant les principales technologies de pointe et émergentes ainsi que les stratégies d'approche commerciale. Jeff s'est joint à CISCO en 1995 en tant qu'ingénieur de réseau. Il a participé à l'introduction de la téléphonie IP et à l'évolution des communications unifiées, ce qui fera l'objet de sa présentation ce matin. En 2003, Jeff a obtenu le titre d'ingénieur réseau éminent, la plus haute distinction technique chez CISCO. Jeff détient un baccalauréat en sciences appliquées avec spécialisation en électrotechnique qu'il a fait à l'Université de Toronto. Jeff's presentation is about defining the new collaboration experience. Collaboration is driving the next wave of business growth, innovation and productivity. Please welcome CISCO CTO, le directeur de la technologie chez CISCO Canada, M. Jeff Seifert.
Thank you. Good morning, bonjour. I thought before we would get into a bit of the discussion, I find it fantastic, and thank you very much. Very happy to be here today. Very happy that it's been 20 years. It's hard to believe. In fact, CISCO ourselves are celebrating in the next week, maybe week and a half, our 25th anniversary. So really, RISQ started at the very beginning of the internet, literally when probably CISCO only had a few employees. So we'll talk a little bit about maybe a little bit of what has happened in terms of network evolution. And if you'll bear with me for a few minutes, I'd like to talk a little bit about kind of the evolution of CISCO, and then talk about where we see things going. So there's a tremendous amount of innovation. The acceleration of the pace is happening faster than anywhere else or any other time I've seen. And as you can see, networks are growing tremendously. Lots of exciting projects happening here at RISQ as well. So if you look at CISCO, and I'm not sure how many people have been involved with CISCO for a long time, 20 years is a very long time, and with networking, but the first router came out, for those that don't know, actually was put together by a couple, husband and wife, in Stanford University who worked for different departments. And they couldn't email each other to coordinate for lunch and things like that. So they actually put together and built the concept of a router. And then they found their peers, much like in this room, they found peers that said, hey, we could use that at our universities as well. So CISCO was actually founded out of people in this room in universities that wanted to figure out how to communicate. So we find it really inspiring that our first customers were universities, and as we've grown over time and we've expanded in the first few years, it was really came up with our first product, the AGS router. I don't know, has anybody ever configured an AGS router? We have one? Oh, there's more than one, there's many. They had ribbon cables, very old router, RS-232, low-speed connection, 19.2 kilobits per second, a lot different than the bandwidth that Nancy is talking about now. And I think that was actually one of the first routers that was actually at RISQ, was an AGS, I think the plus version in the very early days. So as CISCO grew, we actually came to Canada. We opened up an office in Toronto and then very quickly an office in Montreal. And we've been in Canada for a long time. I actually got involved with CISCO when I graduated in 1992, and I was at Bell Canada, and Bell Canada being the first CISCO partner in Canada, and put in products. So it was very interesting as we learned and started building multi-protocol routers to deal with not only TCP/IP, but Banyan, Vines, DECnet, lots of other protocols. As SNA came on and IBM mainframe networks came on to IP, routing really grew. We went into a long series of acquisitions that have become many products. And it's very important. Cisco, we actually have expanded and grown, and the network has grown by not only doing a lot of research and development and listening to our customers, but doing acquisitions as well. So a lot of people probably have Catalyst switching. That was our first acquisition, Crescendo. That has become a very, very big part of our business. So over time, as you continue on, we went into other markets. We went into putting not only different data protocols together, but putting voice, putting video. A lot of you may have IP phones as an example. We acquired a company called Celsius Systems that was the first IP phone out there, and we kind of looked at there was a big market inflection point. Got very involved in trying to get students in high school and cégep and public schools to be involved in networking. So I don't know if anybody went through Network Academy or has helped teach with Network Academy, but the idea is to get people and the kids involved, and that is something that's been going very, very strong for almost 13 years now. Over time, we've gone and grown. We acquired additional companies. We got into storage area networking with the acquisition of Andy-Ammo, go into home, and we see a connected home as being a big trend going forward, and we'll talk about that with Linksys. As you continue on, entertainment, Scientific Atlanta, and really just tremendous growth in terms of entering new markets. And continue on, and when we started, when Canada formed, there was only a few hundred people. We're now at a point where we're at over 65,000 employees, so fairly large. We continue to have business units, a tremendous amount of innovation. We spend over $5 billion in research. We have what we call 30 company priorities going to 50 company priorities. And so we've gone very much from a command and control where John Chambers, our CEO, makes all the decisions, to independent business councils running that make decisions collaboratively. So collaboration is absolutely key. And what we want to do is talk more about where do we see some things going. And there's a tremendous, and not just the networking, but in terms of how the network can actually improve life, and as we call it, work, learn, live, and play, enhance that ability. So it's phenomenal opportunities. We really appreciate everyone and the ideas and working with us and having the loyalty to actually trust us to be a part of your network. So going forward, we see the network really evolving, and we see some strategic focus areas. So some of these focus areas, and we're going to dive into these a little bit more, is around video. It's quite clear. You see the news headlines. Cisco's bringing out lots of video products. We're acquiring companies in video. It's really not only just the video that drives bandwidth, but it's a collaborative experience. It's a very rich experience in terms of encouraging teamwork. So we really see that as the media experience. We see some of the consumer applications out there, the need for business applications in video and even enhancing. So we'll talk a little bit about that. Same with collaboration, really allowing to move from text and emails to that kind of video-rich collaboration. And then we're talking about connected communities. How do we deliver services? How do we deliver electrical power? How do we deliver healthcare? How do we provide the connectivity and new experiences and the safety and security around communities? So a lot of focus on that. And then virtualization, as applications and servers have virtualized, as you go to cloud computing, as you go to clouds within your organizations, what is the evolution architecture on that? So if we look at the future of work, the future of connecting to life, and the future of computing, there's some distinct priorities. So each of these are actually a high priority within Cisco. So we're going to go through some of these in specific example and give you some ideas in terms of where we see things going over the next 5 years. So if you look at collaboration as an example, and video and collaboration, traditionally, maybe in the last 5 years, it's been a lot of email, a lot of text, a lot of file sharing. We're really seeing interest in terms of how do you find people outside the people you know in context, find the right person at the right time. How do you know who has the right skill sets and experience? How do you make that a richer experience? How do you ensure that it's real-time and non-real-time combined? So we see some of that kind of changing. Video is absolutely key. So I don't know, how many people have been on a telepresence session? Has anybody been in telepresence? Wow, it's almost at least a third, maybe almost a half. Very different than a traditional video from years and years ago. It's very lifelike, very interesting. What's interesting is on the opposite end of the spectrum, the flip video that you see there, the little handheld that's a bigger than this, but not that much bigger than this, is something that's one button touch, super easy use. In fact, we're going to give out a couple of those as prizes today in a draw. But it's very simple and easy to use. You flip one button to record, you flip another button to USB, and you plug it into your PC or your Mac. And you can upload and share a video. Well, taking that simplicity, as well as the simplicity of the high video definition experience, to other devices, like video-enabled phones, that you could take a recording of some research, plug it into the side of the phone, and share it with a community. And maybe that's a team that's a trusted team. Maybe it's within one university. Maybe it's across multiple universities. So there's some policy and security around that potentially. But allowing that simple ease to use to really have this kind of any-to-any video type experience. Working on a lot in terms of integration, interoperability. You're seeing a lot more of this coming, tying to mobile devices. So that video, for instance, in the telepresence, well, what if you could record that and maybe record a message or a conference or something like that, and then record it real simple, don't have to go into a studio, and then using a phone interface as an example, send it out so it could go out to other telepresence rooms, but also to digital signage, to desktop video, maybe out to something like an iPhone or a BlackBerry. And this is the type of things that we're doing a lot of experimenting with, and we're seeing a lot of customers doing and a lot of research going on in terms of the user experiences and how to make the different form factors work. One of the things that we looked at was telepresence was great. Telepresence within an organization. Within Cisco, we cut our travel, about $300 million of travel out. Dramatically improving our greenhouse gas emission and reduction. 27% last year alone we reduced our greenhouse gas by as a company, and a lot of that was travel. So telepresence, phenomenal. But how do you get between organizations with telepresence? We decided to create a seed, an exchange point, and now it's something that's being rolled out around the world, much like in the internet. You have the internet connection peering points. We created a telepresence peering point. And one of the very first ones we did was with some key customers, some of the largest global customers like Procter & Gamble and such, and Walmart. But we also did one with what we called the University Connection. So we worked with, in this case, with some US universities, and we had created a University Connection network. And so we see that expanding. We see that expanding to other countries, and we hope that some of the institutions here will be a big part of that in terms of collaboration, so that in between any two organizations, you can actually have that high definition video type of experience. So you'll see a lot more happening on that. Something that's happening in the next couple weeks. So probably seen some of the news and been following that climate conference in Copenhagen is coming up in 2 weeks. And one of the things that we've had the privilege of is to be able to work with the United Nations and with the Danish government to actually create a whole telepresence exchange, much like the one we talked about for the university, where we're actually putting telepresence at the conference, at UN sites around the world. We're connecting into Cisco offices. Some of the universities will be connecting in as well to allow people to have virtual meetings rather than having everybody have to fly in to a climate conference. So it's kind of interesting in terms of the expansion, where things are going with that as well. And that's something that's not just one time. That's going to be ongoing. So you're going to start to see the availability for research, for conferences around climate, for public suites that you can rent, and really tying together and really changing the experience and hopefully having a pretty big impact in not only reduction of travel, but also collaboration. So telepresence is great. But how do you take that kind of experience of video any site, without having necessarily full telepresence and enable it for everything? One of the challenges has been we've deployed telephony, and a lot of organizations have probably gone to IP telephony and voice over IP. And when you look at how do you get between organizations, I bet a lot of organizations in here have voice over IP, but then they use TDM circuits. They use things like ISDN to connect between the organizations, so when you call each other. What about creating secure, encrypted, trusted, authenticated IP connections that could go over, for instance, the RISQ network and allow for not only just the traditional voice, what's called narrowband voice, but go with wideband voice. For those that have deployed IP phones from Cisco and others, you probably have the capability of going wideband, which is high fidelity voice. You probably have a lot of desktop video clients, room-based video conferencing as well. Some of you may have telepresence. Wouldn't it be nice if you automatically could route that and didn't have to go through PSTN circuits, like ISDN? And so that kind of connectivity is something we see happening. We see it being fairly early in terms of the adopters being probably in the education and research, but also corporate, the corporations in Canada are fairly interested as well, driving IP connectivity. So this is an opportunity that we're doing a lot. You're going to see a lot being released over the next year in terms of a release that's coming out in 2 months. It's really going to allow this to happen in a secure way and allow SIP connectivity just to simply dial with a trusted connection between organizations on either the internet or private network. We're seeing a lot of customers and organizations wanting to allow users to have custom social media. And there's a lot of tools, social media tools that are out there that are absolutely fantastic for the consumer. Many are being used for business. But there's no policy. There's no concept of building private teams so that you have some security in terms of what you're sharing and things like that. But people love it. It's very easy to take video. Those flip videos, it's very easy to take a quick video and post it up on YouTube as an example. But how do you constrain that to a team of researchers that are working together as an example? So we're entering a market where we're trying to create enterprise versions of social media applications where we can tie in your soft phones, your wikis, the blogs, video soft phones together and make this a Web 2.0 portal with identity, with policy on the back engine side. Ability to post, make it very easy to record video. And again, we're trying to make these things, and these things for us are kind of loss leaders. They're creating demand, starting ideas, open APIs that people can embed into their other applications and other products, and giving you some of the toolkits. And so we see, and we're hoping to see, a lot of uptake, the same way that we see within Cisco internally. About 70% of our employees now record videos. And it's important that not only recording videos, but they're automatically, with the new tools, being transcribed so they can be tagged with the key content words. So one of the interesting things that we did was we posted an iZone, what we call iZone. It's a wiki at Cisco. And we realized 65,000 employees, not all the best ideas are going to come from a few product managers. And so what we did was we posted this iZone wiki and asked people, incubator site, to post ideas of what they think could be a really good product. And we had one systems engineer in Italy say he had a problem. He had a really tough time finding who had expertise all around the world in a specific subject he was looking for. And he would call his peers. His peers would say, well, try John. And John would say, try Sue. And they would eventually maybe find somebody. They would watch email threads. And mailers at Cisco have gone so out of hand. I joined Cisco 15 years ago, and I thought I got a lot of email then. Just to try to keep up with all the technologies and all the email threads is just impossible. So the concept was, what if we could watch across the network for who has, from a tagging perspective, who has experiences? Who's answering emails posted to threads? Who's posting web pages? Who's recording videos and posting them in blogs, wikis? And so by watching the network and having these tools in the network, we could actually make suggestions to people. Suggest to Christine here that she's got some expertise in terms of the service provider type of accounts that you cover in Canada. Suggest to Rob that he's got an experience in having done optical in his past life, as an example. And suggest to them the tags. They can opt in. And so our directory, instead of being a self-tagging directory, we tried that. That failed. We tried to do a Cisco directory where people tagged what expertise they have. Everybody did it the first time. Nobody went back to it and updated it later. So we've actually introduced this, and we actually trialed this in Canada as the first place at Cisco. And what we did was we deployed it, and basically all the engineers, all our specialists, basically get suggestions on tags. It looks like you're doing a lot on digital signage today. Looks like you're doing some things on video surveillance. Suggest tags. And that allows people all across Cisco now to actually find where there's some expertise. What's really interesting is when we as a team in Canada were collaborating and saying on the alpha version of this, doing research on would this product make sense, we all said, it's really nice to know that Christine's the person I need to go to, but where does Christine go to get the information she needs? That would be more useful, because I personally would rather go and look where Christine's looking, see if I can help myself, rather than always calling Christine. So with this product, we actually took a lot of input, and it literally was about 1,000 people to help form input and ideas into this before the product has actually come to the market, which was just released in the last few weeks. And with that, we pull in things like, for instance, with Christine, if she went and got her information most of the time or contributes to videos, we take videos through an experience engine, we call it, that automatically transcribes it and pulls out the tags. So I can pop up a video and I can see exactly where in the video the content I'm looking for is. So starting to come up with some really neat ideas in terms of within an organization of how you could actually do collaboration tools. One of the interesting things of really working with customers. I live in Toronto, and I worked with a customer and some of our engineers called Sheridan College. And they had a bit of a problem where very heightened sense of security, given all the problems that have happened in the US mostly, about potential students with weapons. And they had a video surveillance camera that picked up a student walking through with what looked like a rifle hanging out of their coat. It was a tripod. They had to lock down the entire college, and they realized they had very poor tools to lock down the college. It was very difficult to actually go through and lock down. So when they, after the incident was, and it was in the news and everything, and it was very safe, it was a mistake, they realized they needed a better communication method. They'd already deployed things like IP telephony. They deployed some digital signage in limited factor, and they had their web portal for the school. And what they did was they used the, basically, they used basically the Cisco Unified Communications to what's called an applications engine, the Unified Applications Engine, to actually develop a tool that would go out, and when the security desk went through a web portal, securely authenticated, they could issue commands and lock down the university, send messages to one wing or one lab, or the entire school. And they built it so that from this one interface, they could send messages to the displays on phones. They could turn on the speakers of the phones and make every phone in the school a paging system. They looked at how they could do digital signage, update all the signage, update the college webpage, call out to prescribed lists of cell phones so they could call out. They're looking at integrating to the radio systems, so the handheld security guard radio systems. And again, by just tying together these applications, they can actually coordinate things. So when you look at where that's going, those types of things in terms of notifications, again, the IP network's really that foundation, create some tools, and there's a lot of other opportunities. What if in a lab there was a noxious gas, a hazardous situation? What if they could trigger and automatically trigger not just overhead fire panel, but messages to the phones and coordinate around? What if they could tie it across to the smartphones with more information to this? So we're seeing a lot of these types of how to coordinate across multiple types of technology as being a trend that we're seeing a fair bit. In the whole concept of virtualization and cloud computing, I think people are fairly familiar with this concept of data center 3.0, that really as it went from a mainframe to the power of distributed computing, client server, having servers in every branch spread out to the sometimes chaos of trying to manage applications across so many platforms, to the concept of virtualizing, centralizing back to a data center, having things like vMotion and such for disaster recovery has been a big trend, and trying to simplify and go back to that capability. So we're seeing a lot of where it started with things like doing 10 gig and gigabit and Ethernet in terms of networking servers in the data center, and then doing storage networking, and then doing unified fabric to try to reduce the number of connections between the active connections and the ILO connections and the SAN connections down to a pair of 10 gig connections in the servers to simplify. And we're now seeing lots of customers that have obviously virtualized many of their applications using VMware, Xen, various other virtualization engines, and then looking at mobility, so the ability to move those between data centers, to potentially move those even into a card on a router, so doing some offload to branches. And then really this concept of being kind of a utility where within an organization, there's compute, and you go and think of it from a cloud computing, and you just go and use CPU as you require it. So we're seeing a lot in terms of happening in that perspective. So simplification on unified fabric, moving from having all these separate Ethernet connections and fiber channel connections to having fiber channel over Ethernet over a pair of 10 gig connections. We have, I'm sure everybody has worked with virtualization, things like VMware, and you've probably seen things like VNLink, which is basically Cisco saying instead of having to be a hardware-based LAN switch, we can embed all the technology that you've built in your networks into a software-based LAN switch that can go in the hypervisor for the virtual machines and extend. So you can allow virtual machine to virtual machine, security, policy, QoS, all those types of things. We're going to be coming out with a network interface card that will allow that virtual machine to virtual machine, that VNLink with a hardware assist. So you're going to see, again, more and more tight coupling. We've done joint announcements with both VMware and EMC as an example. We have a consortium where we have putting a tremendous amount of investment in terms of testing things as solutions to provide simple to use, complete turnkey type data center offerings. But you're going to see a lot more in terms of the virtualization. And one of the areas that we're working on, it really is working out all the details of how to take the vMotion as an example. If you're familiar, vMotion is the concept that I can take a virtual machine, move it over to potentially a disaster recovery site. And right now, there's white papers that we can do that up to 80 kilometers, and we can move it between virtual machines. You're going to see it so that you get to the active-active. So the concept is a virtual machine's running, and the increments, the deltas on that virtual machine get replicated over to another virtual machine running on the other side. So you can create active-active without having to do application layer clustering. So a lot of work in terms of that. Some of the challenges are the good old layer 2, layer 3. vMotion liking a lot of layer 2, layer 3. So things like LISP protocol is something that's been a lot of work been happening to ensure some of that layer 2 scaling. You probably heard about things like unified computing. And this is Cisco's entry not to blade servers, but to an entire chassis platform that's simple to provision. It's optimized for things like using standard-based memory to get together in extended memory arrays to get very high amounts of memory for virtualization, and has some huge benefits in terms of rolling that out. So if you think of that VNLink, talked about the LAN switch that's now in software in the hypervisor, and you think about how you would map that to not only VLANs, but to perhaps VPNs and the MPLS network. We have seeing a trend where people want to, within virtualized machines, run different applications that may have to map to different VPNs. And so kind of the merge together of what is called IPNGN and has a basis of MPLS, of keeping different types of traffic separate, consolidating everything on IP into virtual machines, then in true cloud fashion may have different customers' applications, different departments' applications that need to be absolutely more than just VLAN separated. If we look at smart connected communities and the concept of how can the network go much further into these communities than just simply hooking up our broadband internet connections. What are the things they could actually do to change our lives in terms of how we work, live, learn, and play? So some of the things that are fun right off the bat. I don't know, did anybody get to go to the NHL All-Star game? I didn't either. So, and that was in town. Maybe next year. That was in town. It was pretty neat. I see actually Francois Leclerc. I'm sure some of the folks know Francois Leclerc from our office. But we actually have this initiative called Connected Stadium. And we're trying to change the experience of the fan and make sports. Because with high-definition TV, you can go to Future Shop or whatever, and you can buy a very nice TV, and you can sit on your couch at home. The sports teams are having sometimes a tough time getting people to come to the events and pay a higher price for the ticket because the quality is so good on the TV now. So they're very eager to change the experience of the fan. How to use technology to make the experience of going to a live event TV better. So one of the first things that we did as an experiment here in Montreal last, was it February, I think, was at the All-Star game, is we had telepresence out at the fan and with the players. because it didn't make sense to bring Ovechkin in the picture out to the crowd in the intermission of the game or just before the game, but to bring the fans through telepresence and the life experience. And so a lot of children, a lot of fans got a chance to meet some of their favorite players. And we've done this at the NHL, we've done this at the NBA. So that was the first of trying that. We also did some interesting things in terms of renovating the Toronto Blue Jays in Toronto with Rogers Centre. And in the US, there's been a lot of new stadiums opening. The Dallas Cowboys, the Miami Dolphins, and the New York Yankee Stadium that opened. And this is probably the most sophisticated stadium anywhere in the world. There's a huge one being built out in South Africa for the World Cup. And there's projects pretty much everywhere around the world happening now. But to really look at things like how do you change the experience? And so one of the things that we did, and we first prototyped in Toronto for the Blue Jays, and we've done it with New York now, is the concept of being in maybe a box or the bar where you can control the screens from a phone and use it as a display. You can pull up any camera angle in the stadium, and you can see it. You can see replays, things like that. So again, looking at technology, smartphones, video feed to smartphones, that is the next wave that's going to be happening over the next couple of years. And so a tremendous amount of opportunity to actually change it. It's just an example where it's more of an entertainment example. Healthcare to areas outside of urban centers. So here's some pictures from a location in Scotland, but we're doing some things that potentially in Canada as well into northern Canada. If you think about it, if you're in the far north of this province or the far north of the territories or any other province, very hard to get a doctor or specialist. Very hard, you pretty much have to put a person on a plane and fly them into Montreal or Ottawa or Toronto or Winnipeg or somewhere so they can actually see a doctor. So the concept of being able to take that same very high definition video experience, match it together with taking medical instruments and connecting them to the network. So having them streaming over IP or tunneled in IP, whether it be a stethoscope, blood pressure monitors, ultrasound, an ECG, being able to do remote blood test monitoring, tie that together, link it with the same video so the information flows together, and be able to link it to specialists who have different skill sets, and be able to have a call routing behind that to actually send that in the appropriate location. So that's what we deem as health presence, and that's something that we're very active in, and that's something that we think that could have a fairly big impact for some people in Canada. The question is, how do you get some of this high quality, multi-megabit type bandwidth from community to community into very rural areas in Canada? And one of the things that we're looking at is how do we scale broadband by leveraging a program that we call routing in space, internet routing in space. And interesting enough, it was actually Monday morning, I think it was Monday morning or Sunday night, that there was a launch of one of the Atlas rockets that took up a new satellite, the Intelsat 14 satellite. And on board was the Texas runoff, was a new type of Cisco router. This is the first one that was launched. We paid for this one to be launched, and we're doing in conjunction with two phases. First phase is we're doing some with the U.S. Department of Defense. Second phase is to contribute as part of doing research with communities such as yourselves, with service providers and satellite operators and potential universities and such. And the concept of why would you have a router in space? So if you think about two northern communities in the very far north of Quebec, maybe to in Nunavut as an example, up on Baffin Island. Today, if you wanted to have video between the two, you would probably have to go up to a satellite, down to a teleport, maybe in Ottawa or Montreal, and then back up to a satellite and back down on the other side. And so you'd have like two hops back and forth the satellite. The delay, the jitter, and such would make video very intolerable. But what if you wanted to actually have video between those two communities and they were on different types of technologies? Maybe one is on C-band and one is on KU band as an example, and you want to actually adapt that. So by having a router in space, essentially multi-protocol, supporting different satellite waveforms, you can actually convert. And so we see some applicability of actually doing that natural extension of satellites carrying routers in space, which I know sounds a little bit far-fetched, but it's interestingly enough, that's some of the testing we're going to be doing when we launch it this week. start thinking about beyond PCs and Macs. I love my Mac. And we go into things like sensors and putting IP stacks on sensors. So we released together with Swedish Institute of Computing Sciences a stack, an IP stack, an IPv6 stack as well for sensors. And in December, we're releasing open source code. We're releasing some routing elements into that as well. And the concept is that you can actually put IP in very lightweight type stack and start networking together devices, whether it be vehicles in motion. In the mining industry, as an example, keeping track of all the heavy equipment is a huge problem in a place like a mine in northern Quebec. Where are you going to find it? Looking at just the connected home. Looking at patients. How do you do really low-cost self-patient monitoring that allow patients to live at home and take health care to them in the home? So this whole concept of smart object having sensors is something that's very interesting and a phenomenal area that we have some of our best engineers in Canada and around the world working on right now. And we think that there's probably a ton of research that you folks are already doing and a real opportunity for us to work together. Some of the interesting applications of that and spin-offs of that is one of the things that we announced, I think it was April or May, it was earlier in the year, which is this planetary skin initiative. And the concept was putting sensors, connecting them in IP to monitor environmental conditions around the world. So it's something that we're supporting NASA with. And this got posted yesterday in Time Magazine as being one of the 50 best inventions or innovations in 2009. So very interesting when you start thinking about if we can have monitoring around the entire planet to what are the emissions, what's in the rivers, what are the sea levels and everything, and really have a complete picture of the world. Smart grid. So I think everybody's probably familiar with electrical utility grid. Generally in the past, it was centralized sources of power generation. A lot of hydroelectric in this province. Nuclear in Ontario, as an example, is fairly big. Yeah, but there were a few sources, very centralized. It was based on estimating what demand is, looking at the weather and saying it's going to be a really hot day, so the air conditioning in Montreal is going to be turned on today, and we have to crank up the generation. And then if it didn't happen, there's a lot of waste. A lot of susceptibility because the devices were not managed. And you saw some of the things that have happened over the years with widespread outages that people could not react to fast enough. So the whole concept of smart grid is the ability to monitor and manage the electric utility grid. Realize that there's changes. There's changes in creation. There's micro-generation, a lot of wind power. People can generate their own power, put it back onto the grid. So it's not just a few large dams and nuclear power plants. It's many, many sources of power now. The distribution is changing. The consumption is changing. With new cars that you can plug in are going to have tremendous difference in terms of what the requirements of the power grid are. So there's a lot of effort happening on what's referred to as smart grid. And really what it is taking this grid where you have on the left side your traditional generation, add the micro-generation to that, the distribution and transmission right into the customers, whether it be businesses, industry, or the home. And by having smart metering, being able to predict much better what types of power you're going to need to affect what the generation should be, to reduce waste, which will, in fact, if you're in Ontario, for instance, the peak went so high that when they believe they need more power, they start burning natural gas because they're out of power and they don't want to have not enough in the summer when the air conditioners need to be on, as an example. So by equipping and putting metering and intelligence all through the network, CISCO will make many of these, but there will be many vendors that make these, much more intelligent management of this. If we look at and feedback and mechanisms, sorry, too many builds. Really what this translates is to multiple networks. And if you look within one of those, being a building, so if you look in this building as an example, there'll be heating systems, there'll be lighting systems, security systems, fire panels, video surveillance systems. It's ironic. It's kind of back to when we had that AGS Plus router when RISQ first put the network in place, and the world was multi-protocol. There's still multi-protocol within buildings. There's typically things like Modbus and various different protocols, and every system runs in a silo, and they're all proprietary. So the multi-protocol, while many things in the world have gone IP, there's still other types of systems. So it's really kind of just another wave, kind of like voice coming into IP, video coming into IP. We're now seeing building automation systems, what we call connected real estate, and bringing these through mediation devices onto IP so that we can actually provide intelligence back into the network to make decisions. So as an example here, we actually acquired a company called Richard Zeta, who makes a little gateway that speaks multi-protocol, all the building system protocols. And you connect it in, and it transports it IP on the other side, provides XML interfaces so you can write your own applications. And we've got a lot of partners doing a lot of interesting research. We've got partners looking at doing predictive on upcoming weather tied together with the building stats. We've got real-time smart metering happening between tenants. The ability to look at the health of systems like boilers and determine that they're not operating at peak efficiency and maybe do maintenance and repair before there's an outage in terms of really trying to increase efficiencies and such. So we're seeing a lot of different connections, a lot of different protocols. We're seeing a lot of more devices coming on IP, huge with video. And really, again, that connected community changing in a great deal. So just really, in summary, it's been fantastic. We've really appreciated being a part of your networks for the last 25 years, solving a lot of challenges. There's been a lot of new applications that have come on board. We get most of our ideas from our customers. It's absolutely fantastic what the acceleration and the growth and the pace that's happening at. And we really think, again, IP and the research and the IP connectivity and the growth that you guys are experiencing is what's going to drive some things that are actually leading to some really big fundamental changes in terms of how we work, live, learn, and play. So thank you.
Merci beaucoup, Jeff. Thank you so much, Jeff. Est-ce qu'il y en a qui auraient des questions sur la présentation de Jeff? Ça va? Oui.
Hi, Jeff. I'm Gary Bernstein from McGill University. What's Cisco's roadmap for standards-based telepresence?
If we can turn this back. Perfect. So standards-based telepresence. So telepresence, when it came out, was leveraging video. It's H.264 video, and it is standards-based on that. One of the things that we came out that was a little bit unique was we tied together 3 screens. Instead of doing 3 H.264 screens independently, which would allow potential out-of-sequencing, alternate packet, 3 IP addresses, parallel paths and such, we inverse mux them together. And we did that because it wasn't a standard that exists. So we've actually submitted an IETF draft for that, and that either been submitted or will be submitted within the next week. We announced it 2 weeks ago to try to drive that as a standard. And pretty much everything that's out there, there hasn't been a standard for multi-screen inverse muxing that I'm aware of. It has been non-standard. But the basis for pretty much Cisco and pretty much everybody else has been H.264 AVC video. The key is how do you tie multi-screen, multi-camera experience into a single stream and do that in a standards way. So much like anything, and there's always going to be innovation, and then you contribute it back to standards work and adapt to whatever the standard turns out to be. So as the standard evolves, and it may end up a little bit different from how we currently do it, we'll adapt to the standard. And the same thing we've done with Power over Ethernet, things like CDP becoming LDP-MED and various different things. Did that answer your question? So we're going to actually, so the submission as a standard to create a standard or as a draft and some community is this month. In terms of adhering to when that's actually standardized, I don't know how long it'll take through IETF for that to become an actual standard, but we'll be changing that as soon as there is a standard out there.
But typically for those kinds of hearings, it's usually
Yeah, and what we've done in the interim is, and we're actually shipping it now, is we have an adapter through an MCU that will take a single screen as an example, or multiple single screens, and bring them into. So you could have, and we actually have this live on the Cisco network, you could have, for instance, Polycom, Tandberg, and Lifesize as 3 competitors or other products out there filling each of 3 screens. Or you could have 3 Tandbergs or 3 Polycoms all interoperating to full screen, and we'll do high def or interop from that perspective. But a true telepresence multi-screen standard is a couple of, probably a year to 2 years away in terms of actually finalizing, but it's going through the drafts now.